So I've got an alternator I want to test, and it's charging. It says 14.2 volts, but it's a new modern one, and it's got a sensor that's got a digital signal coming into it, and it's a square wave, and I'm thinking it's 5 volts. And so I read on the internet it should be about 90 Hertz to 120 Hertz, depending on which model it is. I'm going to research one. Mine's a Mitsubishi, and this one will control the frequency, and this one will control the duty cycle, which means the length of time the square wave is turned on or off. Because this one will, if we get this right to the model, then the frequency, then the duty cycle should adjust the voltage of the alternator output to test, make sure the alternator is working okay, and it's not the computer on the car that needs sorting out, because the computer on the car sends you a signal to the alternator, say like when it's braking, to charge the car up more because it wants to slow the car down, and then when it's accelerating it turns off the charging, so the car goes faster basically. So we've got 5 volts coming out of there, going to one side of the potentiometer, a variable resistor, and then the other side is going to the ground, so both the grounds are connected, both positive connected, and in the middle pin it goes to one of the two. I'm using 0 and 1 analog pin on the Arduino. Can you see that there, look? And then the output for the output for the alternator is coming out of digital pin 9, going over to the rail and coming out these two wires here. So we'll measure on an oscilloscope the output, and then we can adjust the variable resistors. So I've connected one of the variable resistors up, and it's working. Look, goes from 0 to 1023, which is good enough for me. We're just using the analog read serial example program that you can get hold of easy. So we'll just add another sensor to that, another switch, sorry, to that. So I've just made a bit more code, added another analog pin in, and then printed it out onto the screen. So there's the results of the two variable switches. So as you can see, as I turn one down and up, it moves, and then turn the other one up and down. So they both go to, that goes to 123. This one goes to 123, so we're all happy. Turn both down. There you go. Perfect. So if you see, this is the example program, and it says delay 1, is it 1,000th of a second or one? It's 1,000th of a second between the readings, so the electronics goes stable. So we want it to run a bit faster, the program to run faster through the code. So we're going to put probably read this once every 1,000 cycles of the code, perhaps. Just read the switches, the variable switches every so often. So it's not going to slow the program down, because otherwise we don't want to delay it and then start doing our sine wave, because otherwise the sine wave would be stopped. It'd be restricted to 1,000 hertz. You'll have to excuse because I don't understand it really. So I'll put a for-n loop in, no sorry, a for-n, an if statement in. So if the timer reading, it starts off in 0 and 1, sorry. So on the first cycle it will go into the if statement, read the analog pins, and then it's going to get rid of the prints because that slows it down. And then once it's finished that, it'll plus t by 1 until t equals 1,000, and t will go back to 0. Then which time, so it's done 1,000 cycles by then, so that's more than enough to read the just to give it a steady reading, and it'll go back to there again, and it's working. Yeah, perfect. So this is a program so far. I've not managed to get the duty cycle worked out properly, and the frequency is working okay. I'll show you. So as I adjust this one here, that does the duty cycle down to 0, up to maximum. But as I adjust the frequency, just got to adjust the program. Get in there. Well, I put this bit of code in there, simple bit of code, but it's not quite right, as you'll see. So now we can adjust the what do you call it, the duration. After 50% it goes off the scale to 100%, unless I'm not sorting something else. But when I do adjust the frequency, let me show you here a little bit better. This down the lower end. So if I adjust your frequency now, then the duration or the duty cycle stays the same, roughly. Just with that one bit of equation. But let me show you, that's a problem. Look, when it goes above 50%, it cuts out. So I'm going to fiddle about the program a bit more, see if I can get it worked out. Yeah, there you go, look. It might be the scope. So I got fed up trying to work out the equation on the Arduino, so I used the BBC Basic for Windows. It's a lot easier, and that's the equation I need. I'll just run it and show you. So this is, say, let's put it at 1023, and then it should equal 100% duty cycle. Oh. And there you go, 100%. So left hand figure is the frequency, and that is how long it stays on, the duty cycle. So that's 100%, saying if there's 50 cycles for the frequency, it's staying on for 50 of them cycles. So if we put in, let's say 50%, which is 500 and, oh, was it 12 or 511 roughly, or 12. So now we have got 50%, look, 50, 24, 100, 49, 150, 75 roughly. So that is a 50% cycle. So the equation's working there, so let's lower it down, let's put it to 100. Roughly 10%. Roughly 10%, so we should get, yeah, 10% of 50 is 5, so 4.88. 10% of 1,000 is 90, is 100, 97. So that's working. We'll put that onto the Arduino then. So I've got the equation in it, it's working eventually. I had to use floating variables. Yeah, I had to use floating variables, so we've got decimal points. I thought it was long, I was using long and it wasn't working. So after all that, a pain in the arse into this C++. It is working but not perfect. So here's the frequency. So if you do it all the way, it stays on, and you do it all the way the other way, it gets lower, but anyway. And this one increases the duty cycle, so it stays on all the time, or virtually goes off. And then if you put it sort of, let's say 50%, let's get it to 50, and then you adjust the frequency, it should stay the same, but it's not. See, it's at 47, but it's not bad. I mean, it's only when you get to the higher frequencies that it starts changing. Then you'd have to, that's at 42 there, look. Then you would have to go back and adjust it. But we'll get a basic working model. I'll just, the alternators work on about 90 Hertz to 120 Hertz. I'm going to look into it, but I'm going to see what else that is on here, see if we can recreate it. So this is the program I'm going for. It will give me 90 Hertz and 120 Hertz, which is what it's told to do, use that someone else has used. Yeah, that's about it really. So now we'll put this into a little box. Use an outdoor junction box from B&Q's. That's a hardware store in Lincoln, in the UK. So here we are, have a box. Oh, I wanted to put a screen in there, but that's going to be a bit more work. Got the screws. Um, 7mm then. 7mm drill. I don't know what happened. They already had holes drilled in the centre though, but they went off quite a bit. That one rubbish. 2 dials fitted. Oh, that's me blind closing. And I'm going to put a power supply socket on the back. Just there. Arduino blind. I've got all the wires soldered on. I used some heavy duty wires. Looks a bit of a mess, but hopefully it'll all work out in the end. Just been watching another video on YouTube. I found one with a Honda Genesis and 2010, and that uses 12 volt sine wave. And I think, to be honest, I think they all are 12 volts. Shelley, we're filming. So instead of this going to 5 volts off here, I'm going to have to put a relay in. Bloody cat. Yeah, I've got a few solid state relays. Use the smallest one, obviously. Look at this hoofer log. And what about that one? Whee! That's a few kilowatts, that is. Yes. I'm not playing with you. Okay, so I've got the solid state relay wired in. What I did, these wires that was coming out here was going to the pin, the smart pin on the alternator. So I put the earth onto this is going to be 12 volts coming in now onto this side, and then this 12 volts coming out the other side goes to the relay and out to the other side of the pin, to the positive side of the pin. So now it's going to have a 12 volts, hopefully sine wave, square wave, and pin 9 is coming from there, which was 5 volts. Now goes 5 volts into the relay to turn the relay on to activate the 12 volts. So it's gone from 5 volts to 12 volts. And the earth and the power, 5 volts in. I hope I got that right. Anyway, so I'll test it out then and see if it works. Well, I've tried that solid state relay, there's nothing coming out of it. So whether it's broken or whether it's a DC input and an AC output. So I'm going to try this one, which says on it, can we zoom in? Oh, I can't focus in on that. It says on it DC to DC, so we're going to try that. DC to DC, you can't see that. It's a bit bigger, probably slower. Well, as you can see, we've got a 12 volt waveform now. Sorry about the cable being in the way. But the trouble is, it's not exactly a square wave anymore. It's more of a hacksaw blade wave. And you can take it down. I need to go down to 5 milliseconds. Or is it? Yeah, milliseconds. And it does go down to 5 milliseconds for the... Oh, and it drops off there, starts playing up. But if you play with the other knob, so it's not perfect. I think we're going to have to use a transistor. So if I turn that's the other one for the Ford is 20 milliseconds for a Ford, so that's there. So actually it will work for a Ford. Yep, you've got 100% duty cycle. Yeah, and it needs to go down to about 37. 34, sorry. Anyway, so I think that might work. Oh dear. It depends whether it's just, it needs an actual sine wave for a computerized device, digital device, or it needs it for the just a voltage. I mean, if it's just a voltage level, then it won't matter about that little sine, that little curve there. Well, the transistors have arrived, and I don't know which leg is which. I'll have to look on YouTube. And you just connect 12 volts to one leg. The middle leg, I'm sure, is the trigger, 5 volts, and the bottom leg is the drain, or well, I'll find out anyway. So this is the diagram I'm going to use. I've looked on the internet and done a bit of research. This isn't quite way round to match these legs positions, so we'll have to just move that anyway. So we're all connected to the earth, Arduino, 5 volts through the resistor to the gate, which is this left pin. Then we've got a 10 kilo ohm resistor down to earth to stop it to getting static and whatever it is. This is to slow the impedance down because it doesn't take too much. And then your power supply is connected to your load, and then your load negative is connected to your your drain. And your source is connected to your ground. Easy as that. Okay, so I've got it wired up, and this is where the 12 volt is. Well, I'm going to have that as the earth 12 volt, and this is the positive. So I'm going to put my clamp meter across here because I've got no load. So at the minute, nothing could be going through the transistor, the Mosfet. So when I click my clamp meter on there, hopefully in my oscilloscope it should work. Right then, I'll turn the power on. A bit doubtful whether this is going to work or not, but there's only one way to find out, isn't there? That's got 12 volts going in. Oh, we've got nothing. Oh dear. I think it's... No. Need to put a load across there. It might be better to connect the power supply up. That might help. I do say that. Right, we'll try it. I'll just put this wire on and try it. Right, then connecting the power any minute, any second now. Here we go. Nothing. Oh, I've got a spike, look. Oh dear. Well, that didn't work, so I've just tried this relay, this other solid state relay, and this one doesn't work either very well. It does work, but I'm not getting a reading on my oscilloscope at all. I've gone back to this relay, and it's a bit strange. I think it's got a loose wire, but it's worked sometimes, not others. But look at that, look. If you put a bulb on here, on the load, and you get a better square wave. If I take that off, look, get a hacksaw wave again. Put that back on. So turn the duty cycle up, 50%, 60, 70. I mean, I'm happy with this, but this is the wrong speed. 57 milliseconds. We want 20 to 5 milliseconds. I'm starting to wonder whether the alternator just works off a voltage rather than actually the signal. So it won't matter too much about the frequency. Let's bring the frequency to 20 then. See if it'll work. 20, 20, 20. That's alright. Right, let's take it down to 0. Yep. It won't work in a minute ago. Oh, that's fantastic. I think we're happy with that. I think we'll leave that bulb in the actual case. See, it's an indicator of it working. So let's go to 10 now. Oh dear. Let's go down to 10. Off. Oh, I'm getting happier. Oh, that's fantastic. Yep, that's 100% duty. Right, let's see how fast it will go then. Before it cuts out. 7. Oh, we've got 10 to 5. I think 7 is the lowest I can get it down to. 6. Then it starts going funny. Whether it's my scope, to be honest, it could be my scope, wouldn't it? Oh, let's turn the scope. What have we got? 2 milliseconds. Is that wrong? Have I gone the wrong way? I go that way, don't I? That's even worse. Anyway, we're getting there. Just dropped the delay down in the program from 100 microseconds to 25, so that should speed it up by 4 times. So let's try it out now then. 25 milliseconds, and we're right onto the left hand side. Oh yeah, that's good. Will it ditch out at 7? Yeah, it's gone at 7 again, look. Yeah. But the range is better on the dial. That's full range, that's slowest. And it was 100 or so last time, I can't remember. But see if we've still got the duty cycle. Yep, so that's at 12. I'm trying, I've got a notepad here somewhere where it says 200 Hertz to 90 Hertz is what we want. It doesn't say Hertz anywhere. Oh, it does at the top, look. Frequency. Oh, I'm getting confused now. Well, a bit of a hallelujah moment. I took the, I cleaned the program up. I took the serial begin 9000 statement out, and I took the serial print line command out because that slows the computer down. I could speed up a little bit more, but I think we're doing alright now. So there we go, look. I want to get to at least 5 milliseconds for the quickest alternator I've found. So now it's gone past 7 and we've got down to 5, look. 5 is 200 Hertz, which is for I think it's a Honda something, or so you can increase the duty cycle at 5 Hertz, and it's working. And take it down. Yeah, so I think we're finished. That's it, we'll call it a night with this job. And trouble is, I haven't got an alternator to test it with because the bearings have not turned up for this Subaru Impreza alternator I've got that I was built this for. So you have to wait for next week. Let's give a little, I've just done it with the soldering iron a little bit to start it off, and then it's 5mm this bulb is. Champion. Now this is a bit tricky, I've got to put it under there. Oh wait a minute, let's get deburr the back of it. Come on, go in there. Yappa! Look at that, look. Oh, you can't see it, look at that, look. Beautiful. Put a bit of glue at the back, and we'll solder this earth connection on. You know, when the glue's dried and you're finally finished, that's when it goes wrong, isn't it? That's bloody sod's law. There you go, look, something bad connection. That's working now. So where's the bad connection? Is it down there? Oh my lord. I'm just going to change this whole solid state resistor relay, sorry. Changed it over, there's the old one, and it's still doing it. Where the... Well... Could it be? Bloody things, aren't there? What there? It's not this side. That's tight. That's not making no difference. I might have to solder these two wires together, see if that helps. Look at that lot. Yeah, we'll solder them two wires together. Bloody things. You know, I've had enough sometimes. I think this wire here is playing up. Oh, it doesn't do now the camera's on, does it? There you go, look. It's still, that won't make no sense though, because it's working now. So it should start working properly. Look, press it down. That light goes out. But that's nothing to do with that, because this is still getting power. Oh, I tell you what. Bloody things. Well, I found it. It's this wire's come off. Where has it gone to now? Oh, it's gone. I've put all extra wires into there to make sure it's not positive and negative and the signal. But it was this green wire on here. It's got, there it is, look. If I touch down there, it should come. There you go. That's working perfectly now, look. Oh, sorry, let's turn it up. Yeah, so that's it. I'm going to have a fag and a can of lager and finish it off. Yeah, I'm sure I'm haunted by ghosts of electrical stuff, because look, it's working. What's going on? I've soldered that one on back on, look. It must be the problem. What the? And I've tried putting an earth onto it and it still plays up. Let's try putting an earth from there and wiggling it about. See, that's got an earth on it there, still wiggling about, still playing up. Oh, oh sharp, we've got sparks, we've got smoke. Oh, I've got the wrong side, have I? Yeah, I got the wrong side. Oh dear. Oh, now I've ruined it, look. See, wiggle that about and it comes back again. But I've tried jumping this. Oh, is it that one again? Look. Bloody things, look. Now that's loose. That's come off now. Bloody hell, oh. So I've got that wire back on and now we've got. Look at that, look. It comes back on when I press that now, look. Haunted. Bloody electric. So what is the problem now then? What is the bloody problem now? Is it one of these wires? Is it all three of them? Come on, give me an hand. Give me a break, you bastard. Jesus Christ, the bloody electrics. What's going on? What's loose? What a pain in the... There's about 8 million problems. See, it still does it. It's not this side, I've tightened these up. Oh, is it? No, it's still doing it a little bit. Let's tighten them up a bit more. Perhaps that's it. I'm sick of this. Oh! Are we there? No, not perfect. Tighten these up a bit more. Bloody things, aren't they? I want to settle down and have a drink. If I put the cover on, you know what's going to happen, don't you? It's going to stop working. We're down to 3 milliseconds there, which is great. I'm happy. Take it to 5, back to 5, and we'll try the cycle. Yeah, that's it. We're working. There you go. So we've got 5 milliseconds, which is 200 Hertz, which is the maximum we need. We can turn it up. We can turn the duty cycle down. Oh, this is great actually. Quite happy. So we can, let's go to a slower frequency. 90 is what the Ford Focus, what I've heard. Oh, what have I done? .9. Yeah, that's 0.09 I think. That's duty cycles working. Yeah, I'll change this one for you. Oh. So that's it then, kids. So we change the frequency with the left hand switch and change the duty cycle with the right hand switch, and everybody's happy. Oh, apart from that bit there. Right, time to put the lid on. I've got to press that bit down a bit, so no doubt when I've got it all assembled and the screws down, it will start going wrong again. That's Sod's Law quotes. Remember to only put 12 volts in there, don't put anything higher, just in case. So we're about done then. I've only got a 9 volt power supply, obviously need a 12 volt one, but it does actually still work with 9 volts, but obviously it's 9 volts on the square wave, but it does work. So apart from putting some labels on the top to tell you what part of the buttons are, we're done. I'll put a circuit diagram out in a minute. I'm just drawing that now while I'm drinking some beer, so it might not look very good. So that's about the best diagram we're going to get at this time of night. There's the crocodile clips going to the alternator. One crocodile clip goes to the earth, and the other one goes to the pin, the C pin, the COM pin on your alternator. You've got your on a Mitsubishi, oh sorry, Mitsubishi alternator. You've got your L pin for your lamp, and you get S for your sensor, and you've got the C, which is your this is what we're doing about the C comms. So there's your 2 variable switches, 50 ohm switches. Right hand side is duty, left hand side is frequency. Going to A0 and A1 analog pins. So all the earths are connected to the Arduino, plus the socket and the relay. So it's not too complicated. And I'll put the program in the comments in the morning probably, if depends how long it takes. Yeah, like I said, I can't test it out on an actual alternator until next weekend, because the back end bearings haven't turned up. They said they're out of stock, so I've had to order them somewhere else. So I can show you it working next weekend if you want to see it.